The reason why we have to continue our journey in trigonometry is because the Pythagoras rule does not really solve all our problems. We know trigonometry just means measuring the length and angles of a triangle, but the Pythagoras rule does not really solve all our problems. All that the Pythagoras rule does is to help us find the missing side of a right angle triangle. Just the missing side. Once we have two sides, the Pythagoras theorem or rule help us find the missing side without giving any information about the missing angles of any right angle triangle. Now for this right angle triangle ABC, we know that the side facing the right angle, that's the angle 90 degree, is called the hypotenuse. While the other two sides, AC and BC, are called the legs. But let's say we have an angle theta here. This angle theta could be 40 degrees, 50 degrees, 30 degrees, or 72 degrees. But I just decided to use theta to represent the angle there. So let's say we have an angle theta here, for example. Now if we have an angle theta here, this side here, the side BC, which is opposite to the angle, will be called the opposite. It's called the opposite side. It's called the opposite side. While the side adjacent to the angle theta is called the adjacent. Or we can just say the side that the angle 90 degrees and the angle theta touches is called the adjacent. This side AC is called the adjacent. Now you notice that the angle 90 degrees touches the side AC and the angle theta also touches the side AC, or we could just say the side that is adjacent to the angle theta. So that's the adjacent. So that's how we find the other sides when we are considering a particular angle in a right angle triangle. Now let's look at this other triangle, still ABC. Let's say we have our angle. Let's say we have our angle here as the same theta. Let's just put the angle as theta. Now, how do we identify the sides here? We know that the side facing the angle 90 degrees is called the hypotenuse. So I could just write here hypotenuse. This side facing the angle 90 degrees or opposite to the angle 90 degrees is called the hypotenuse, while the side opposite the angle we are considering is called the opposite. Alright, opposite here. That's this side BC. And the side adjacent to the angle we are considering, which is theta, is called the adjacent. Let me write this out. Adjacent. So this side AC is called the adjacent, or we can just say the side where the angle we are considering theta and the angle 90 degrees touches is called the adjacent. So this is a bit different from the case where we had to use the Pythagoras theorem. We talked about just the hypotenuse and the legs, but in this case we are looking at the opposite and the adjacent. Now from these right angle triangles, we can bring out some interesting ratios. And let's consider the triangle ABC, the right angle triangle ABC. Now from here we can bring out the ratio opposite all over hypotenuse. Opposite all over hypotenuse. And this ratio is called the sine of the angle we are considering. The sine of the angle we are considering, which is theta. Now, let's say we are considering the ratio adjacent all over hypotenuse. Adjacent all over the hypotenuse. Now, this ratio is called the cosine of the angle we are considering. Cosine of the angle. I'll put theta here. So this is called the cosine of the angle we are considering. Now let's say we are considering the ratio opposite all over adjacent. The opposite side all over the adjacent. This is the opposite all over the adjacent side. Now this ratio is called the tangent of the angle we are considering. The tangent of the angle, which is theta. So this is tangent of the angle theta equals to opposite all over adjacent. Now these ratios we have here are called the trigonometric ratios. Trigonometric ratios. Now the trigonometric ratios is just the ratio of the lengths of two sides of a right angle triangle. Notice we have to take the ratio of just two sides, this side BC, which is opposite, all over the side AB, which is hypotenuse, and that gave us the sine of the angle we are considering. Here we have to take the side adjacent all over hypotenuse, adjacent AC all over the hypotenuse AB, and that gave us the cosine of the angle. And when we took the opposite all over the adjacent, that gave us the tangent of the angle. So this applies to any right angle triangle. So we call these ratios the trigonometric ratios. And instead of writing this as sine, cosine, or tangent, we can make this short, and we would have something like this. For sine, we can just write sine as SIN, then the angle theta, and that's all. So this still represents sine of the particular angle. So instead of writing opposite here, I could just take the side BC. I could write BC here to represent the opposite all over the hypotenuse, which is AB. This is AB. I put AB here. Now for cosine theta, instead of writing the cosine like this, I could just write cos theta to represent cosine, and this is still equal to the adjacent side is AC. So I write AC, while the hypotenuse is AB. I'll put all over AB, still the same thing. While the tangent of the angle, instead of writing tangent, I could just write tan theta, which is still equal to opposite, that's BC. I'll write BC all over the adjacent, which is AC. All these are called the trigonometric ratios. Now for memory aid, instead of writing sine theta equals the opposite of hypotenuse, cosine, and tangent, for memory aid, instead of writing all this, we could just write this as, since sine is opposite all over hypotenuse, I could just say sine, which starts with S, then the opposite, which stands with O, then hypotenuse, which stands with H, meaning sine equal to opposite all over hypotenuse. Then for the cosine, we have cosine starts with C, then adjacent starts with A, then hypotenuse starts with H. While for tangent, the tangent starts with T, opposite starts with O, then adjacent starts with A. So you see we have SOHCAHTOA. We can just use this as a memory aid to remember the trigonometric ratios. This is called the SOHCAHTOA. They are all called the trigonometric ratios. Now the interesting thing about the trigonometric ratio is not like we just use it to calculate the angles and sides of triangle only. We can actually apply this in real life situations. For example, we can use the trigonometric ratios to find the height of mountains and also towers. Apart from that, we can also use the trigonometric ratios to find the distance between celestial bodies like the sun, the Mars, the distance between the sun, the Mars, and maybe the Earth, and other celestial bodies too. And also, architects use trigonometric ratios to calculate structural load. So I believe as we dive into this interesting aspect of trigonometric, you'll find it very, very fascinating.